Okay, we're going to do a quick run through of a gas law PowerPoint right here. So the problem is oxygen gas generated in an experiment is collected at 25 degrees Celsius in a bottle inverted in a trough of water. The external laboratory pressure is 1.0 atm. When the water level in the originally filled bottle has fallen to the level in the trough, the volume of the gas is 1,750 milliliters. How many moles of oxygen gas have been collected? Okay, so we're going to be working with the ideal gas law equation. This is written out as PV equals nRT, or, fun way to remember it, PervNRT. Since we're looking for n, we're going to rewrite the equation so that we're solving for n. So n equals PV over RT. N represents the number of moles in the system, P represents the pressure on the system, V represents the volume, R represents the known R constant, and T represents the temperature of the system. What do we know? Okay, in the problem it told us that pressure was given to us at 1.0 atm, however the system was at 25 degrees Celsius. Since it's at 25 degrees Celsius, we're going to need to go consult a water vapor chart. If we look at a water vapor chart, we see that at 25 degrees Celsius, pressure is 23.8 millimeters mercury. If we then take 23 millimeters mercury and divide it by 760 millimeters mercury for every 1 atm, we're going to get 0.0313 atm. If we then subtract it from our initial given pressure, we're going to find that our pressure value is 0.969 atm. What else do we know? Volume. Volume was given to us at 1,750 milliliters. However, our R constant unit is in centimeters cubed. We have to be consistent and have consistent units, so in order to cancel, we're going to need to convert the volume to centimeters cubed. If we take 1,750 milliliters and multiply it by 1 centimeter cubed for every 1 milliliter, we'll get 1,750 centimeters cubed. Luckily, it was a 1-to-1 ratio in this problem. It's not always going to be like that. What else do we know? R constant. Okay, R is a known constant given to us at 82.054 centimeters cubed, Kelvin to the negative first power moles. Okay, that number is a known experimentally tested value that will be given to you by a textbook, a professor, a TA. You're not going to know it off the top of your head, but it's going to be given to you. You're going to just have to remember to work with it. Temperature. Temperature is 25 degrees Celsius. As we saw in our R constant, it's in terms of Kelvin. Well, 0 degrees Celsius is equivalent to 273 degrees Kelvin. It's really simple to just convert. All you have to do is take 273 and add it to the initial 25, and you get 298 degrees Kelvin. Alright, let's go solve it all. So we went and found all of our different variables, and we have that equation, n equals PV over RT. Let's just go plug in the values. So we take 0.969, multiply by 1,750, divide by 82.054, and multiply by 298. Notice we have ATM. We have ATM. Those cancel. We have milliliters. We have centimeters and milliliters. I wrote that out wrong. Sorry about that. Those cancel. We have Kelvin to the negative first power. We have Kelvin here. That cancels. All we're going to be left with at the end of it is going to be moles, and we'll have our final value, 0.0694 moles. Therefore, in that problem, the number of milliliters in a trough when it's inverted at those values is going to be 0.0694 moles.